So we're recording. So now we have seen that people are having some trouble with this section on composite functions. Now there's some tough questions in the section, but the basic process is something that we've been over a couple of times. So I'm going to go over it kind of quickly here, but you want to be sure you understand this. Okay, so if f of x is this function, 1 over the quantity x plus 3 squared, g of x is 1 over x minus 1, then f of g of x, well, if f of x equals 1 over the quantity x plus 3 squared, then f of g of x, where x is now replaced by g of x, is 1 over g of x plus 3 quantity squared. And g of x, in turn, is 1 over x minus 1. So now we have 1 over the reciprocal of x minus 1 plus 3 quantity squared. Now, in order to do that, we have to do a little bit of algebra. And one of the reasons I had you work the preliminary problems on fractions is so you would understand how to add fractions and so forth. Okay, so let's just look at this 1 over x plus 1 plus 3, this denominator. If you multiply three times x plus 1 over x plus 1, and of course that's the same as 3 over 1 times x plus 1 over x plus 1, you get 1 over x plus 1 plus 3 times the quantity x plus 1 over x plus 1. Now, since we have the same denominator, we can add the numerators. Gives us 1 plus 3 times the quantity x plus 1 over x plus 1. And this equals, well, the numerator simplifies, 3 times the quantity x plus 1. And I'm going to go ahead and do all the gory detail. That gives you 3x plus 3 times 1, which is 3x plus 3. Then we add the 1 and the 3, and we get 3x plus 4 over x plus 1. So that this denominator is now this. Now, what's this mean? This means 1 divided by 3x plus 4 over x plus 1, because this means 1 divided by whatever's down there. And to divide by a fraction, you multiply by its reciprocal. So that's 1 multiplied by x plus 1 over 3x plus 4. And of course, that just equals x plus 1 over 3x plus 4. Okay, well, the simplification is a little bit challenging, but the algebra is a prerequisite for this course, so we expect you to be able to do this algebra, especially since we've reviewed it, at least after you've seen me do it, okay, if you need a refresher. But this algebra is something that's expected, so you might have to review a little bit of algebra in order to do this, because I'm not going to have time to go through all these details and explain the things that we need to understand in this course. Of course, if you have questions on that, please ask them. I can always do a video explanation or just give you some advice through email. Okay. The main thing, though, is that you have to understand that f of g of x means x has been replaced by g of x, so you replace the x by g of x. And then you write the expression for g of x. And then if you don't know what to do with that, at least put that expression into the answer and see what MyOpenMath, I keep wanting to say website, see what MyOpenMath tells you. It might reject your solution because it's not simplified, but then I can review your stuff and see, well, yeah, you did that correctly. I'll probably give you half credit for just doing this correctly if you can't simplify it. Now, the other half has been able to simplify it. What I really want to see here is understanding what it means to do f of g of x. The algebra, after getting to this step, is the other half of the question. And people typically at this stage do need to upgrade their algebra a little bit. Okay, well, what's g of f of x? Well, g of x is 1 over x minus 1. So g of f of x is 1 over f of x minus 1. And f of x is the reciprocal of x plus 3 quantity squared. And then that's minus 1. And at this stage, I'm just going to write it down. It's 1 over, well, we're going to have to multiply this 1 by x plus 3 quantity squared over x plus 3 quantity squared. It's going to give us 1 minus x plus 3 quantity squared over x plus 3 quantity squared. Just imitating this. And now let me digress and show you a little bit of algebra. Okay, so x plus 3 squared is x plus 3 multiplied by x plus 3. By the distributive law, x plus 3 multiplied by something is x times that something plus 3 times that something. So we could write this as x times x plus 3 plus 3 times x plus 3. Okay, then we use the distributive law again. X times x plus 3 is x squared plus 3 times x. In other words, x times x plus 3 times x, which is x squared plus 3x, plus 3 times x plus 3 times 3. And that equals x squared plus 6x plus 9. Okay, now if you don't understand that, I said it fairly quickly, you really want to kind of come back here and look at this part of the video. Okay, so this would then be 1 over, now 1 minus this, 1 minus, well, minus x squared is negative x squared, minus 6x, and then 1 minus 9 is negative 8 over x plus 3 squared. Then I've got 3 dots here. That means you need to understand this step, imitate this when it means 1 divided by all this. I'm not going to write all that out now. But that's then x plus 3 squared over negative x squared minus 6x minus 8. And of course, that equals negative quantity x plus 3 squared over x squared plus 6x plus 8. Okay, there's a fair amount of algebra there. Oh no, we might get cut out of this meeting. If we do, I'm going to be quite upset. Because Zoom just popped up and says it wants to reinstall itself. It's done that in the middle of a meeting before. I've emailed our technicians, and they say they fixed it, so it will actually let me snooze for 2 hours, which I selected. I've done that before. It hasn't worked. Okay, so I'm going to hope that we don't get cut out, because if we do, the recording is gone. But I'll have the boards and I can repeat everything I just said in another video. Okay, well, there is the process. So that's about as complicated as the questions get at this point, because the algebra is a little bit complex. On simpler questions, well, look at previous videos. I've done the same thing on earlier videos. Incidentally, if Zoom does cut us out, I'll be able to send you a link. The reinstall is very quick. You should receive another link within 2 or 3 minutes, and then you can rejoin the meeting, or join, actually, it would be a new meeting. Okay, and I do see, I don't remember whose work I'm looking at right now. I see a correct substitution on a problem like this. So it's as if you got to this point, but then didn't know how to complete it. So in a couple of days, when everybody's had a chance to finish their work on this, I'll go back and look through and see if there are cases like this where you've done the correct substitution. So if you did the g of f of x correctly, which was done correctly here, you only lost half credit, but I'll restore half of that half credit. I'll restore you 1/4 of a point on that. Okay. Now we want to look at domains and ranges. Okay, so we're going to continue with this example and ask, what's the domain? See if I can get back to the screen here. Okay, the domain of this function, well, you're inputting x. X has to be input into the g of x function, and that means x can't be 1, because if so, you have division by 0. So I'm going to say x is input into g of x, which is equal to 1 over x minus 1. So x can't be 1. If it is, you have division by 0. Now, what else can't x be? Well, x can't be anything that causes g of x to take a value that makes f of x 0. And what that comes down to is your denominator here can't be 0 either. So 3x plus 4 can't be 0. Now again, in section 1.3, you saw how square roots, if you have a square root, the quantity has to be negative has to be at greater than or equal to 0. If you have a denominator, it can't be 0. So you use what you did in section 1.3. Three x plus 4 is equal to 0 if and only if x equals negative 4/3. Okay, you can easily solve this equation. Subtract x from both sides, divide both sides by 3. So I'm not going to go through the details of that. So you have to exclude x equals negative 4/3 from the domain. Now I see that you're not able to quite see something I wrote down here. Remember, you're welcome to wave your hands, jump up and down, put something in the chat if you can't see everything on the board. There it is. Okay, so the domain of f of g of x is then, in interval notation, it'd be all numbers less than negative 4/3 union all the numbers between 4/3 and 1. Don't think I said the negative and 4/3, but there it is. Union the interval from 1 to infinity. Now you can visualize that, and it doesn't hurt to reinforce what you're saying here by saying, okay, here's 1, and here's negative 4/3. So we've got to exclude these, this one and this one. You exclude them by taking the interval from negative infinity up to this point, from this point to this point, and then from this point on to infinity. And you probably ought to really put a circle around this so there's a picture of your domain. Now, in the case of this function, you have to exclude x equals negative 3 because that messes up the g of x or the f of x function. Okay, so you can't put negative 3 into this function because it's going to give you 0 in the denominator. And then you also can't put x squared, whatever the solution to x squared plus 6x plus 8 equals 0 would be. So we have to exclude solutions of x squared plus 6x plus 8 equals 0. Now, theoretically, you should be able to solve that equation. You can factor it. X plus 2 times x plus 4 equals 0. So x equals negative 2 and negative 4 would be excluded. But right now, I'm just going to say it excludes the solutions, plural, of this equation. Negative 2 and negative 4 But we haven't gotten into quadratic equations, and you haven't been refreshed on how to solve that. You can solve this one by factoring. You can always solve a quadratic equation using the quadratic formula, which I'd recommend that you review. Quadratic formula, okay? And how to use it so that when we get to it, you already know and you don't have to stumble over remembering the quadratic formula and how to use it. Well, that's a couple of problems related to difficulties that people are apparently having. There's another thing with another problem that you can have for composite functions is finding the two functions that make up a composite function. So what we want to say is, okay, suppose h of x is 2 raised to the 1 over x power. We want to write h of x as f of g of x. Okay, well, the logic of this is x is input into what function? X is input into g of x. Up here, x gets put into the calculation 1 over x. So I'll say the first calculation in 2 raised to the 1 over x is 1 over x. So x is input into the 1 over x function. Thus, g of x is going to be your 1 over x. Okay. What's the next thing that happens? Once you've calculated 1 over x, then you're going to calculate 2 to that power. So you're going to input that into the 2 to the x function. Thus, f of x equals 2 to the x. Check. If f of x equals 2 to the x, and g of x is 1 over x, then f of g of x equals f of 1 over x. Since g of x is 1 over x, f of g of x has to be f of 1 over x, which is 2 to the 1 over x. If f of x is 2 to the x, f of 1 over x is 2 to the 1 over x. So h of x is 2 to the 1 over x, and f of g of x equals 2 to the 1 over x. Thus, h of x equals f of g of x. F of x equals 2 to the x. G of x equals 1 over x. To analyze a question like this, you ask yourself, what function is the x input? That's your g of x function. And then into what function is this input? That's your f of x. Okay, now I'm looking to see if there's another question of that form. And let's do a simpler one. What are the f of x and g of x functions such that h of x equals 2x plus 3 to the 4th power?
Professor, can you please write in bigger letters? It's getting hard to see.
Yeah, I'll write it a little bigger over here.
Thanks.
Okay, I squeezed it in here to give myself room over here. So the question is, we want to have f of x and g of x such that h of x equals the quantity 2x plus 3 raised to the 4th power is equal to f of g of x. So, okay, well, first calculation you do, of course, the first calculation you do is going to be multiply x by 2, but then you're going to add 3, and you don't have another composite involved like that. So you have the linear function 2x plus 3. Okay, x is input into the 2x plus 3 function. And then, so g of x will be 2x plus 3. And the result is input into the f of x equals x to the 4th function. And you know, I can make it a little easier to read by moving the board over. Might not help much, but it should help down here. Okay. So h of x, which is 2x plus 3 quantity to the fourth, equals f of g of x, which equals g of x raised to the fourth power. Since f of x equals x to the fourth, f of g of x equals g of x to the fourth. And of course, g of x is 2x plus 3 to the fourth. And this is equal to this. Okay, that should give you the flavor of how to do some of these questions. Now, as I emailed you, yesterday, there's a new, quote, course that I've put into my open math that you can go to if you're late with an assignment, and work for half credit, work the assignment for half credit. Now, since the homework is basically only worth ballpark of 2 letter grades, meaning if you don't do the homework, you're sacrificing 2 letter grades. Half credit is basically worth about 1 letter grade. So if you did half credit on all the assignments, you'd only be sacrificing 1 letter grade. Now you don't want to sacrifice any letter grade, so you do want to get your homework done on time. But in the future, any problems you do after the due date, if you don't use a late pass, you can get half credit for. Now, if you've used a late pass and you still don't have a very high grade, so that half credit would still be an improvement, you can still do the half credit. If you've used a late pass, if you just haven't used a late pass and you work for half credit, you'll get full credit on anything you've done in the regular course, and then half credit for the additional points you get when you work for half credit. And I have to manually put those into the system, which means I'm not going to be scanning it every day, but at least once a week I'll go down and scan the, compare the 2 grade books and make changes when necessary into the actual grade book for your course. So hopefully that's clear. But basically you have the opportunity to work for half credit, and the deadline on those assignments is sometime in August, which is way too late for this course, but I wanted to make sure they stayed available through the end of the course. Okay. And so some of you might choose to do that on this assignment. And if you run out of late passes, you can still, work for half credit. Okay. Now that took up a lot of our time, but we still got time left. There were 2 things I wanted to do today. I'm only going to be able to do one of them. Actually, I'll be able to mention the other because it's very, very simple. Because these are 2 ideas that you're going to need to understand. So let's see what I've got from board space here. One of these days, I'm going to buy a couple of 2x4s, redo this thing so it doesn't wobble, bring my tools down here, and do a few other things to make all this easier to manage. But so far, it's working okay. Just try to improve it a little bit. Okay, now let's see where I am. If I use the other side of this board, Yep. Okay, I still got this one and two sides on the other one. This one has another side too, but it's rough and I don't like to use it. Of course, if I use it, it gets less rough. Conundrum there. Okay. I'm going to assume that you've done the assignment I gave you for 10:30 or for 1:31 for last Sunday, or that you've at least started on the 4-part assignment to replace that. If you have, it'll be easier to understand this, and that's of course why I gave you the assignment. So you'll be prepared today to understand what I'm going to show you, because it's something people generally have some trouble with. I was trying to anticipate that. So you really want to get these written assignments done so that you understand the thing that they apply to. So you really want to get on top of that. And many of you did. Many of you did quite well on that assignment, but many of you haven't submitted anything. And just to see something here, let me go back here. Okay. Yeah, not seeing many responses, although I have gotten a number of responses to the assignments I posted yesterday. Okay. If you have a function f of x, so here's a graph. Of y equals f of x. If you want to raise every point of this graph by 3 units, and let's go ahead and put a scale on the y-axis. So just go up to 4, 1, 2, 3, 4. Okay. Y equals f of x plus 3 is the same graph as y equals f of x. But three units higher. So to get the graph, you can mark, oh man, my chalk fell into my water bucket. And this room's at refrigerator temperature last night. It's not that much above refrigerator temperature right now. So that water's cold. Okay. But I'm tough. I'll survive it. No colder than the water comes out of the faucet. Let me get that hand dry so I don't mess up this new piece of chalk. It'll dry as long as I don't touch the edge of it. It'll write okay. Okay, sorry. That's the first time in probably 50 years that I've dropped something. Okay. How could that be? I played football. I never dropped the ball. Well, anyhow, obviously none of that is true, except I did try to play football. So I can pick a series of representative points here. And I can take an arrow of length 3 in the vertical direction And this is an upward arrow of length 3. And then I can draw that arrow on every one of these points. And I get points on the graph of f of, not f of x plus 3, but f of x plus 3. Now, why does that work? Well, y equals f of x on the white line, and y equals f of x plus 3 on the yellow line, or at least at the yellow points, because f of x plus 3 has a y value that's 3 more than the y value of f of x. So I can now sketch a decent facsimile of the graph of f of x plus 3. This graph is congruent to this graph. Has the same shape if I've drawn it completely accurately. Now, to be completely accurate, I'd have to do this every point. I don't have time to do it with every point. There are infinitely many points, okay? So I do it with representative points and then try to follow the pattern of the curve. I missed a couple little wiggles in the curve. If I'd have been more careful, I could have made the curve wiggle a little bit above here, okay? Or I could have chosen a better set of points to get all the little subtleties in the shape. But you see that these curves have the same basic shape. It's fairly close. Okay. Now, this one's confusing. Okay, this has the same graph as y equals f of x, but every point is shifted -3 units in the x direction. Not +3 units, -3 units. Now I'm going to give you a written exercise this weekend that'll show you why that is. But right now, that's the rule. If you replace x by x plus 3, it shifts the graph 3 units to the left. So If x is replaced by x plus 3, graph shifts -3 units. And what does f of x plus 3 do? It replaces x in the definition of f of x with x plus 3, which you understand if you understand composites, and you might want to come back to this video and review that once you are a little better at understanding what composites are doing. It takes a little practice, takes some takes just doing some problems. And of course, before you do the problems, you have to understand how to do that. Hopefully, I've clarified that much for you. Okay, well, so if I have a scale on my x-axis, and we'll just kind of use about the same scale as we did on the y-axis, space our units about the same, then I can sketch this arrow, okay? And this arrow is, this thing isn't writing very well, let's try the other, a -3 units in the x. Can't write the whole word direction here, so I'll abbreviate it DIR. So there it is. So in order to get a new graph, the graph of f of x plus 3, f of the quantity x plus 3, we're going to have to apply this shift to every point. Okay, well, so this blue graph is a graph of f of x plus 3. To get the graph of f of x plus 3, composite function, we have to shift to the left. So we're going to apply this arrow to every one of these points. It gets a little sloppy here because the function's not one-to-one, but we'll do it anyway. Yeah, looks about right. Okay, now we have points on the graph of f of x minus 3. F of x plus 3. Easy to get the plus and the minus mixed up, so you got to be careful. Okay, so here, here, and so forth. And then we can sketch a curve through these points. Being careful to sketch the curve in the same order. So here is our graph of f of quantity x plus 3. And actually, I meant to make that graph in a different color. And screen's doing a pretty good job of smearing out that orange. Okay. So the graph of f of x plus 3 is here. Now I'm going to do one more. Looking at the time, okay. So we've got 7 minutes. That's plenty of time to do this. I'm going to try to draw a graph that looks about the same as the one I originally drew. Probably won't do a great job of it. But let me find the original graph. Okay, it comes down here, up through about here. Then it comes up through the x-axis about here. And it's going to hit the x-axis about here after coming down. Yeah, it's going to, and then it's going to do a little wiggle. Then it's going to come down again. And that's not a great facsimile of that graph, but there it is. Okay, so this is the graph of f of x. And we have a scale. Which might look like this, and then similar scale over here. And the x scale isn't going to matter for this graph, because now what we want to do is we want to do the graph of 3f of x. I'm going to use 3 again. Now, I haven't stated that quite precisely, but you have the idea. Every y value is going to be 3 times the y value of f of x. Now, if I wanted to state it completely, I'd say the y value for every x is 3 times what it is for f of x. That I'm going to take to be implicit. Okay, so we can do this. We can sketch a series of points. And now I'm going to sketch a set of arrows indicating the y values. At the various points. Okay, so here are my y values. So these arrows from the x-axis down to the graph or up to the graph represent the y values. So if I've got a scale here, well, here's, say that's x equals 2.1. At x equals 2.1, the arrow is this long. And if I move that arrow over to the y-axis, I see that the length of that arrow is about 2.2. So the length of this arrow is about 2.2, as I see by projecting over to the y-axis. So when x is 2.2, it looks like y is also about 2.2. I didn't intend that, but that's really the way the estimates came out, that they happen to be the same. Okay, here, x is maybe 3, and now y has changed. You can ask yourself, what's the rate of change? But y has changed to a little less than 1, okay? And that arrow has a length a little less than 1. So the length of this arrow is the y value if you take the direction of the arrow into consideration. Now, this arrow, take this one here. If I continue marking off my Y scale, that arrow is about 2 units long, but it's down, and clearly the fact that it's down means that the Y value is -2, not 2. Again, to really understand what I'm saying and lock it in, you need to have done that assignment, or you need to already have good insight into what it means to move points around and so forth. So if you haven't done that assignment, you really need to hustle up and do it, and then view this video again if you don't totally understand what's going on. Okay, well now I want my arrows to become 3 times as long, because the Y values are 3 times as much. These arrows, which represent the Y values, are going to have to get 3 times as long. So how do I do that? So arrows representing Y values must become 3 times as long. So trying to figure out a good color, I think will work. Okay, so this arrow I take, and then I make 2 more arrows down in the same direction. And now from here to here, I have an arrow that's 3 times as long. Okay, so I have I think I have a purple piece of chalk. This purple arrow represents a value Y equals f of x. And I'm sorry to have to write that as small as I do. Let me move the board over. Okay, so this purple arrow represents a value Y equals f of x. And this green arrow is value Y f of x. This value of x here. So now I've got 3 arrows representing the value Y equals f of x, giving me the pinkish red arrow, whose value includes the value of f of x 3 times. So this long arrow represents the value of Y equals 3 times f of x. Well, I can do that for every point. I can draw another short arrow here, another short arrow here. And that's going to kind of interfere with my labeling here, but I'm going to draw it anyway. Okay, so this represents 3 times the value up here. Be lucky to get 3 times the value in here. I think I can do it. This arrow, again and again, same value. I didn't do that very accurately, but you understand what I'm doing. Okay, and I can do the same thing here. It's a little bit lower, but not much. So now I have this. Same thing here, same thing here. And the same thing here. Now I have points on the graph of y equals 3f of x, and I can sketch a curve that behaves kind of like I think it will. We're going to go up here, come around here, down here. There's a little wiggle in there that I missed because of the points that I sketched. But now here's graph of y equals 3f of x. Note that every point on this graph, if I've done it with correctly, every point is 3 times as far from the x-axis as for f of x. So every point moves 3 times as far from the x-axis. Those are your 3 basic transformations. Now there's a 4th one, which is horizontal compression. You can read about that. If you understand these, that one's going to be easy enough to understand. These were all illustrated in the assignment. The only difference being that in the assignment, you move points to the right because I didn't give you a form. I just said, take the points, move them up 3 units, take the points, move them to the right 3 units, take the points and move them twice as far from the x-axis. That was the assignment. If you did that assignment, I think you understand this quite well, and you're going to be able to do it. Otherwise, do the assignment, then think about what I said here again, and you should be in good shape. Or just imitate what the book does. You won't understand it as well, but you'll probably be able to do it, and you won't retain it as well. I'm not getting on you for not doing that assignment, but I'm trying to advocate for the benefit of doing these written assignments. Another benefit is you learn how to write things so that you can pass the tests, because you have to write things right in order to pass a test in this course. Okay? So it shouldn't take that long to do the assignment. And the broken down assignment that I sent out replaces the other. So if you get all 15 points, I'll still give you 15 this time. Next time, there'll be a penalty if you're late. Not a serious penalty if you're not seriously late and if you do it right, but serious enough that you don't want to keep doing that. Okay, so there it is. Well, I'm surprised nobody mentioned I didn't close my parenthesis up there. That's kind of important. Okay. Well, if you got questions, I'll be glad to talk to you. I'm going to stop the recording now.